So for the second program, I'm going to go with one of the exercises from the book. The goal of this exercise is to write a program, guess my number game. When it's finished, it will work like this. I'm thinking of a number between 1 and 100, including both. Can you guess what it is? Let's type a number. So type in a number. Your guess was 45. I was thinking of 14. You were off by 31. So in order to choose a random number, you use the random class in java.util. Here's how it works. Skip that. I'll skip that for right now. Like the scanner class, random has to be imported. Yeah. Let me just read it. Yep. So it tells you the what we want to do. So let's go ahead and take a look at this. So I'm thinking of a number between 1 and 100. So the computer has to choose a number between 1 and 100. How does the computer choose a number? Well, we use a random number. Well, we can just, have a number set up like this. Right? New class. Right? Guessing game 1. Public static void main. Let's go ahead and now let's see what we can do. So we could do something like this. Int secret number is equal to like 44, or let's go with 13. Right, my secret number is 13. Now this would mean that no matter what the secret number is going to be the number that the computer has chosen. Now, every time we play this game, it's going to be 13. That's not really that interesting. What would be more interesting is if the computer chooses a number that's different each time. So, so the user will then take a number. It will guess that number. The number I was thinking of was 14, and you were off by 31. So let's look at how we can get the computer to choose a random number. To choose a random number, you can use the random class in java.util. How does it work? Well, here's an example program. Import java.util.random, public class getStarter, and here's a main class. Pick a random number. Random is equal to new random number. It number is equal to random.nextInt. So let's just take all this in. So we create something called a random object. This is a new random number generator. You can use it just like you can use scanner to read stuff. You can use it to give you random information. So random.nextInt100 gives you a random number from 0 to 99. So include 0, it goes up to but does not include this number. So 0 to 99. Right? Why does it do that? Well, because often we want 0 to be included in a range. When we're doing stuff with a range in programming, we often want to include 0 in that range. And so this is saying we'd like a range of 100 numbers, right? So 0 through 99 is 100 numbers. So this will generate a number between 0 to 99, but we don't want 0 to 99. We would like 1 to 100. So then we can add 1 to that to change it from 0 to 99 to 1 to 100. So let's just grab this and use it for ourselves in our program. Right? That's what they're saying to do. Modify this to change it. Right? Now we'll go back here. It says you want to grab this program, compile and run this program, modify the program to prompt the user, then use scanner to read the input from the user, compile and test it. Read the user input as an integer and display the result. Again, compile and test. And then compute and display the difference. So we want to go and do this one at a time. So the first thing we're going to do is we're just going to grab this source code and compile and run it. So that's what I did. And rather than just grabbing the whole file, I'm just grabbing the little segment I need. Now again, it's giving me an error. Cannot resolve simple random. Not all programs need random numbers. So as a result, we just have as a result, it's not necessarily included by default. So we have to import it, just like we do with scanner. Java.util.random. So it was java.util.scanner, java.util.random for random. So random numbers are pretty useful. So this int number is equal to random.nextInt 100. This bound over here is just a hint that comes from my compiler. It doesn't actually, notice how I'm hitting left and right and it's just jumping around it. It's just something that my compiler's added to, sorry, my IDE's added to help me. So run it. So it's going to print out a number. It printed out 3 this time, 90 this time, 71. See how it's random, and see how it's between the range of 15 or, sorry, from 1 to 100. It's not going to go over 100. It's uniformly distributed, meaning that no number is more likely than any other number. All right. So we can do that. So instead of, so what we can do is that we can make this our secret number instead. Our secret number is equal to that. I'm not going to print it out yet because it's a secret, right? So we choose. So now we can modify the program to prompt the user, right, about what this program is going to do. Let's play a guessing game, right? So now that we have a secret number, it's not so different than any of the other programs. Right, let's play a guessing game. I'm thinking of a number between 1 and 100. Print line. What do you think it is? So now we've got to. So now that we've got to take an input from the user. So it's my secret number is an integer, so that means that the user should probably put in an integer. So we'll put in guess is equal to. Well, we'll need to get a scanner to read the user's guess. So scanner, import it. Scanner, right? I just did a hotkey combination which automatically imported it for me. On my IDE, it was Alt Enter. System.in, right? So this is how we use a scanner. So now guess is equal to the scanner next integer. So we're going to read the guess from the user, and we'll print it back out at them. System.out.println. You guessed plus guess. Let's run it. I'm thinking a number between 1 and 100. What do you think it is? I think it's 20. You guessed 20. Right, and it doesn't do anything more than that because I haven't told it to do anything more than that. So let's go ahead. So now let's go ahead and see if the user was right. System.out.println. My secret number was plus secret number. Let's go with 23. My secret number was 38, so I wasn't too far off, all things considered. All right, so now the last part of this was saying how far off we were, which is a bit tricky. So now we have to compute and display the difference between the user's guess and the number that was generated. All right. Well, the difference is always subtraction. So we could say, let's create a new integer. Int difference is equal to secret number minus guess. So let's run this. I think your number is 1. You guessed 1. My number was 40. Oh, system.out.println. You were off by plus the difference, right? It didn't print out the difference because I didn't tell it to. 40. Ooh, you guessed 40. My secret number was 40. You were off by 0. Should buy a lottery ticket or something with this. Okay? I think it's 1. You were off by 92. So that works for that, but let's say I do this instead. So it seems to be working, and it works pretty well. So what about, though, if I were to guess a number bigger than the secret number? Like 100. You guessed 100. My secret number was 44. You were off by 56. Uh-oh. Negative 56. Right, the difference was 56. So there's a couple different ways to solve this. So I'm going to solve this just using if-else statements. There's an easier way to solve it at the end that I'll reveal at the end that will revolve being, that involves stuff that we haven't learned yet, but let's go ahead and do that. So if secret number is bigger than guess, right? If you take secret number and subtract guess from it, you're going to get a bigger, then you're going to have a positive number. On the other hand, if guess is bigger than this, you're going to have a negative number. It's just the way it's going to work. So what we can do is we can look at, but regardless of how the order we're in, whether it's positive or negative, the numerical amount is right. So there's a couple ways we can do this. I like this way, which is that if negative 50, let's see, if difference is less than 0. So in other words, if we ended up with a negative guess, right? Sorry, if our guess was bigger than secret number and we ended up with a negative difference, then we can just make difference positive, right? Because difference is less than 1. Sorry, difference is less than 0. How can we make difference a positive number? Well, if difference is negative, then you can multiply any negative by negative 1 to turn it into a positive number instead. So we do this by saying difference is equal to difference times negative 1, right? Oh, this is a bit tricky. So this means that, what are we doing? We're taking the value in difference, we're multiplying it by negative 1, and we're storing the result in negative 1. And so now, if I run this code, put in 100, my secret number was 44, you were off by 56. That's pretty cool. Now let's go ahead and try something. So what other ways were there to do this? Well, we could say we could have done it in a different way. Int difference, we could have declared the difference variable. Okay. Well, I'll do that in a second, but another way to do that was to compare secret number against guess. So if secret number was greater than guess, we could say that int difference is equal to secret number minus guess, else the other way. So if it's bigger, secret number is bigger than guess, we use the original equation. Otherwise, we do guess minus secret number, because in this case, guess would be bigger. And I'll just go here and system.out.println difference. But it turns out I'll get an error. Can't resolve simple difference. Now this isn't something we've tackled yet, which is the idea of scope. Okay, and it has to do with the fact that basically that, once we're done with the program, we will want to, once we're done with the program, we really don't need the variables anymore. So the idea of scope, as it's called, the way it works is that anything created inside a pair of curly braces, like main, is destroyed at the end of the removed at the end of that pair of curly braces with the close of it. So once main is done running, anything inside of here is gone. Similarly, anything inside of the if statement's curly braces only exists inside the if statement. So this integer only exists inside of here. Now that's something we'll get into more detail on Tuesday. So the way to resolve this is to just declare the variable that, say, this variable exists outside of the if statement. So anything, right, so the key is anything created inside of a pair of curly braces, you get rid of it once the curly brace is done with. And we get into that in more detail on, not Monday, but Tuesday. So that's another way to solve this problem. So what's one more way? Well, another way is that we can go back to our original idea of just straight out computing this difference. And then we can use a single command to make sure that it's a positive number. There's a math library which has a whole bunch of useful math commands. Math.abs, which will give us the absolute value of the difference. And now that'll give us a positive number no matter what. Alright, so I'm going to go and check on a crying child. So we're done with this program.